world painted green, imagining the unimaginable. Deserts. These vast arid expanses stretch out as far as the eye can see, their golden sands shimmering under the relentless sun. They are places of extreme conditions, where life clings to the edges, surviving against all odds. Vast, arid landscapes where scorching sunbeams dance on shimmering sands. The heat is intense, the air dry, and the horizon seems to stretch into infinity. Yet there is a certain allure to these barren lands, a beauty that is both stark and mesmerizing. These seemingly barren stretches, covering almost a third of our planet's land surface, have long captured our imagination with their stark beauty and unforgiving nature. They are places where the human spirit is tested, where survival is a daily challenge, and where the landscape tells a story of resilience and adaptation. But what if, in a dramatic turn of events, these desolate landscapes were to transform into lush, verdant forests? Imagine the barren sands giving way to rich, fertile soil, and the dry air becoming moist and filled with the scent of greenery. Imagine a world where the Sahara Desert, with its towering sand dunes, morphs into a sprawling woodland teeming with life. Trees would rise where there was once only sand, and the air would be filled with the sounds of birds and the rustling of leaves. Or the Australian outback, known for its harsh conditions and sparse vegetation, bursts forth with a vibrant tapestry of trees. The red earth would be covered in a blanket of green, and the landscape would be transformed into a haven for wildlife. This radical shift, while seemingly a scene from a science fiction novel, prompts us to ponder the profound implications such a transformation would have on our planet and its inhabitants. It would be a change of epic proportions, altering not just the landscape, but the very fabric of life on Earth. From the delicate balance of our climate to the intricate web of life that thrives on Earth, the consequences of turning all deserts into forests would be far-reaching and complex. It would affect weather patterns, water cycles, and biodiversity. The deserts, once seen as barren wastelands, would become vital ecosystems, supporting a myriad of life forms and contributing to the health of our planet. The Earth's climate, a delicate dance between incoming solar radiation and outgoing heat, would undoubtedly experience a dramatic shift with the disappearance of deserts. Deserts, which cover about 1/3 of the Earth's land surface, play a significant role in the planet's energy balance. Their vast, barren expanses reflect a substantial amount of solar radiation back into space, a phenomenon that helps to keep our planet cooler. Without these natural reflectors, the dynamics of our climate would be fundamentally altered. Deserts, with their light-colored surfaces, act like giant reflectors, bouncing a significant portion of the sun's energy back into space. This reflective property is crucial in maintaining the Earth's energy balance. The bright sandy surfaces of deserts have a high albedo, meaning they reflect most of the sunlight that hits them. This reflection helps to cool the Earth by sending solar energy back into space rather than allowing it to be absorbed and converted into heat. This reflective property, known as albedo, plays a crucial role in regulating global temperatures. Albedo is a measure of how much light that hits a surface is reflected without being absorbed. Surfaces with high albedo, like deserts, reflect more sunlight and thus contribute to cooling the planet. Conversely, surfaces with low albedo absorb more sunlight and convert it into heat, warming the surrounding environment. Forests, on the other hand, absorb more solar radiation due to their darker, denser canopy. The dense foliage of forests has a much lower albedo compared to deserts. This means that forests absorb a greater amount of solar energy, which is then converted into heat. This absorption of sunlight by forests contributes to a warming effect, particularly noticeable during the daytime when the sun's rays are strongest. This difference in albedo means that a world covered in forests would trap more heat, leading to a general warming effect, particularly during the day. The increased absorption of solar radiation by forests would result in higher daytime temperatures. However, this is not the only factor at play. The interaction between forests and the atmosphere is complex and involves multiple processes that can influence the overall climate. However, the increased evapotranspiration from trees, releasing water vapor into the atmosphere, could also enhance cloud cover, potentially offsetting some of the daytime warming. Evapotranspiration is the process by which water is transferred from the land to the atmosphere by evaporation from the soil and other surfaces, and by transpiration from plants. This process can lead to the formation of clouds, which can reflect sunlight and cool the Earth's surface. This interplay of factors suggests that the impact on global temperatures wouldn't be straightforward. The balance between the warming effect of increased solar absorption by forests and the cooling effect of enhanced cloud cover would determine the overall impact on the climate. Additionally, other factors such as changes in precipitation patterns, wind circulation, and atmospheric composition would also play a role in shaping the climate. While daytime temperatures might decrease due to increased cloud cover, nights could become warmer due to the heat trapped by the dense forest canopy. The dense foliage of forests can act as an insulating layer, trapping heat and preventing it from escaping into the atmosphere at night. This could lead to warmer nighttime temperatures, creating a more pronounced difference between day and night temperatures. The overall effect on global average temperatures remains a complex question requiring further scientific investigation. Understanding the full impact of replacing deserts with forests on the Earth's climate involves studying a wide range of factors and their interactions. Scientists continue to explore these dynamics to provide a clearer picture of how such a transformation would affect our planet's climate system. One of the most significant consequences of turning deserts into forests would be the impact on the global carbon cycle. This transformation could alter the balance of carbon dioxide in the atmosphere, a critical factor in the fight against climate change. By converting arid, barren lands into lush green forests, we could potentially create new carbon sinks that absorb more CO2 than they release. Forests, often hailed as the lungs of the Earth, play a vital role in absorbing carbon dioxide from the atmosphere through photosynthesis, storing it in their wood, leaves, and roots. This natural process not only helps to reduce the amount of CO2 in the air, but also supports a diverse range of ecosystems and wildlife. The more forests we have, the greater our capacity to mitigate the effects of global warming. The vast scale of desert afforestation would undoubtedly lead to a significant increase in the Earth's carbon sink capacity. Large-scale tree planting projects in desert areas could transform these regions into thriving ecosystems, capable of capturing and storing vast amounts of carbon. This would not only help in reducing atmospheric CO2 levels, but also in restoring biodiversity and improving soil health. This could potentially mitigate the effects of climate change by drawing down atmospheric carbon dioxide levels. As these new forests grow and mature, they would continue to sequester carbon, providing a long-term solution to one of the most pressing environmental issues of our time. The cooling effect of increased forest cover could also help to moderate local climates, making them more hospitable for both humans and wildlife. However, the effectiveness of this carbon sequestration would depend on various factors, including the types of trees planted, their growth rates, and their ability to adapt to the local climate. Different tree species have varying capacities for carbon storage, and selecting the right mix of species is crucial for maximizing the benefits of afforestation. The management of these new forests, which includes regular monitoring, maintenance, and protection from threats such as pests, diseases, and wildfires. Effective forest management practices are essential to ensure that these new ecosystems remain healthy and continue to sequester carbon over the long term and the rate of decomposition of organic matter. The decomposition process releases carbon dioxide back into the atmosphere, and the balance between carbon sequestration and release must be carefully managed. Healthy forest ecosystems with rich organic soils can store more carbon and support a diverse range of plant and animal life. Moreover, the initial process of transforming deserts into forests could release a significant amount of carbon dioxide into the atmosphere. Land preparation activities, such as tilling the soil and removing existing vegetation, can disturb the soil and release stored carbon. This initial release of CO2 must be accounted for when calculating the overall carbon sequestration potential of afforestation projects. The transportation of materials, land preparation, and even the decomposition of organic matter during the early stages of forest establishment could offset some of the carbon sequestration benefits. It is crucial to consider these factors and implement strategies to minimize carbon emissions during the initial phases of afforestation. By carefully planning and managing these projects, we can maximize their positive impact on the global carbon cycle and contribute to a more sustainable future. Section 4, Oasis of Life, from barren sands to bustling habitats. The transformation of deserts into forests would usher in a new era for biodiversity, creating a haven for a vast array of plant and animal species. The once desolate landscapes would erupt with life as diverse ecosystems establish themselves amidst the newly formed woodlands. The increased vegetation would provide food and shelter for a wider range of herbivores, which in turn would attract predators, creating a complex and interconnected web of life. Birds would flock to the trees, insects would buzz among the flowers, and mammals would find refuge in the undergrowth. The once silent deserts would come alive with the symphony of nature. This dramatic increase in biodiversity would not only enrich the planet's natural heritage, but also contribute to the stability and resilience of these newly formed ecosystems. Section 5, A Farewell to Familiars, Desert Dwellers Displaced. While the emergence of forests in former deserts would be a boon for many species, it would also spell disaster for those uniquely adapted to the harsh conditions of arid environments. Desert plants, with their specialized mechanisms for water conservation and tolerance to extreme temperatures, would struggle to survive in the newly humid and shaded conditions. Animals like camels, fennec foxes, and desert tortoises, each possessing remarkable adaptations to thrive in the desert, would find their habitats radically altered. The loss of their specialized food sources, shelter, and ability to regulate their body temperature in a forest environment could lead to population declines and even extinction. The displacement and potential loss of these unique species highlight the importance of considering the ecological trade-offs involved in such a large-scale transformation of Earth's biomes.